Let's begin with finding greatest common factor. So in this example, we have 15x to the power 7 plus 18x to the power 5 minus 36x to the power 4. And I will note that the common factor to each one of these terms is 3x to the power 4. So I'm going to use an equal sign to indicate what's coming next equals the original expression. So 3x to the power 4 multiplied by 5x to the power 3, that gives me 15x to the power 7 plus, now I need my common factor, 3x to the power 4, and if I multiply that by 6x, then that will give me 18x to the power 5 if I multiply these two expressions together. And finally, I want to subtract, and then I need my common factor, 3x to the power 4, and that will be 3 times 12. So just remember that if I multiply this by 5x to the power 3, this will give me 3 times 5, which is 15. Then I'll have x to the power 4, x to the power 3, and remember that is the product rule. That's going to give me 15x to the power 7. I'll get my first term back again. So my common factor is 3x to the power 4, and then I would have multiplied by 5x cubed plus 6x minus 12. So just a point about notation here. If I was going to submit this to my class, I'd do it in the way you see here. Obviously, I wouldn't use different colors, and scratch work would either be erased or on a different piece of paper or very far away from my actual work. Part B, or example B, we have 3t times b plus b. So the common factor here, well, I've rewritten it to highlight in a different color that b is the common factor, isn't it? So I'm going to use an equal sign to indicate what I'm going to do next is factor out the common factor, and then I'm going to have times 3t plus 1. Example 3 is very similar to example part B. We have 3t multiplied by binomial t plus 1 plus the same binomial t plus 1. So that's going to equal, well, I can see the common factor. I've rewritten it so that it's in two different colors. And the common factor is still t plus 1, isn't it? It's very similar to the one we saw above, multiplied by 3t plus 1. In this video, now that we've got the preliminaries out of the way, we're going to learn to factor third-degree polynomials by grouping. This technique will only work when you have a third-degree polynomial with 4 different terms. And notice we can't solve anything here. This is an expression. There's no equal sign in the beginning statement of this problem. I want to be careful to model working with good notation. Over here is where I'm going to describe the grouping process. If I choose my first grouping as these first 2 numbers, now I would not use these red marks when I'm working the problem and submitting it to my class. I'm just doing this to explain the concept to you. You should not use this in your notation. Now the common factor here, the common factor is x squared. And then if I think about these last 2 numbers together, the common factor there is actually negative 12. So I want to think about grouping my 4-term cubic polynomial and factoring each of the groupings separately. So what I would do is start with my original expression. I've got to use an equal sign because what I'm going to do will be equal to my original expression. And out of the first 2 expressions, I will factor out the common factor, which is x squared, and that will give me x plus 3. And in the next 2, the common factor is negative 12, and that will be x, so negative 12 times x is negative 12x, and plus 3, negative 12 plus 3 is negative 36. So in my explanation area here, I can see what the common factor is. The common factor is x plus 3, and then I'm going to have x squared minus 12 as my other factor. So for here, I would have x plus 3, my actual work, and x squared minus 12. I hope you remember that a squared minus b squared is always factored as a plus b multiplied by a minus b, and we have a equals x squared, and b here is 12, so this would have to be the square root of 12 all squared, wouldn't it? Which means if we're going to factor this, it would be x minus the square root of 12 multiplied by x plus the square root of 12. Now remember, this all is my scratch work here. So if I'm going to factor this completely now, I have x plus 3 times x minus the square root of 12 multiplied by x plus the square root of 12. So this is what I would want to submit to my instructor. You don't necessarily have to restate the problem, which I've done here, but in the first step with the first equal sign, I have identified the common factor. So that equal sign means that the initial expression is equal to the one where I found the common factor. In the second step there I factored out the common factor of x plus 3, and in the final step I have factored x squared minus 12 to get a complete factorization.